Okay, now we're looking at just simplifying all radicals like the we have been just saw or simplifying square roots, but there's more than just square roots when we're talking about radicals. There's cube roots or fourth roots or so on and so forth. So just a quick reminder, we were solving or we were simplifying just square roots like this where we found its prime numbers, and then paired them up if they had pairs. One's gone and one gets outside that we paired up. So again, this would be 3 square roots of 2 because that has to stay in. Okay. So what we want to do is just extend this idea to something to this effect. Like if I had, let's say, the cube root, and then that's a cube, not a 3 here. Let's say we had the cube root of, let's say 32. Okay. We're going to still do the same thing. We're going to break this down and find its prime numbers here. Okay. And then instead of pairing them, because it's a cube root, we have to have 3 of one value. So I'm gonna grab a group of 3 instead of 2. And there's just like this was 3 squared and it got rid of that square root. This one, we're going to get rid of 2 of these and 1 will get out. So this 2 is on the outside. And then these 2, they can't pair because they have to have a group of 3 in order to come on the outside. So they just have to stay on the inside, and you just multiply that so it gives you 4. So we have 2 times the cube root of 4 would be what we're looking at here. So when you have this cube root, now we need groups of 3, not just pairs like usual. So think about this. If I had a 4th root, then I need a group of 4, right? And so we can do that if I just, like if this was just the 4th root instead of the 3rd root of 32. Again, I would still do the same thing here as far as breaking this down. It doesn't matter which way you do this, 2 and 2. 4 and 2 and 2 and 2. So I still have the same values, but now I need a group of 4 in order to break one out. So there's a group of 4, and 3 of them are gone, 1 of them's out. So this would be 2 times the 4th root of just this other 2 that's left here. So see how it changes depending on what type of root or what type of radical we have here. Okay. Again, 3rd root, we need groups of 3. 4th root, we need groups of 4 at that point in time. We can also do things with variables. So let's just go back to square roots. If I had the square root of, let's say, yeah, we'll go 12. And then let's say we had variables in here like x squared, y to the 3rd, and then z. Okay? If I was looking at this, I would still break down my number like we've done before, 6 and 2, 3 and 2. Got all my prime numbers here. I'm still going to pair those up. So I've got this pair of 2's, one of them's gone. I know this 2 is on the outside, and then I know this 3 is on the inside. When it comes to my variables, well guys, x squared is just x times x. So there's a pair. One of them's gone and one of them goes on the outside. Y is just y times y times y. I have a pair there, but this other one doesn't. So 1 gone of the y's, 1 on the outside, and then 1 stays on the inside. And then the z is just z, so it has to stay on the inside. So this would be 2xy times the square root of 3yz is what we'd have here when it's all said and done there. So it doesn't, the variables, you're still just going to write them as its prime numbers like x times x, and then just pair them up, or groups of 3 or groups of 4 depending on what we've got in terms of that. Okay. So again, that's kind of how you go about doing that. Let me give you let's go the cube root. Let's go of 112, and then let's say we had x to the 4th, y to the 6th, z to the 2nd. Let's do that. Okay. So again, I'd break down the value here. I'd have, again, 2 and 56, and then 8 and 7, 2 and 4, 2 and 2. So I've got prime, 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 and prime. I need groups of 3 now, so I could go this group of 3 right here, and 2 of them are gone, which means we've got a 2 on the outside. This 2 can't have a group, and 7 can't have a group, so they stay on the inside, and I can just multiply those to give me 14. So I've got my cube root here, I've got the 2 out here. Now I'm going to take care of my numbers. Remember, this is just x, 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 x. So there's a group of 3 there. So I can go 1x on the outside, these other 2 are gone, and then I have an x on the inside. Then I've got my y's, y, 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 y. Really just think, how many groups can I make? And I can make 2 whole groups, and then there's nothing left, so that would be y to the second on the outside, because boom and boom, which means there's 2 of them. And then I've got my z to the second, z and z, which I can't make a group of 3, so that just has to say z squared on the inside. And that would be it. So again, just to recap, your variables you just treat like however many there are, and if you can pair them up or group them up in groups of 3. If I'm dealing with a cube root, I've got to have groups of 3. If I'm dealing with a 4th root, groups of 4. Okay, so on and so forth. All right, that's it. Math Moment out.